A rogue black hole, no bigger than a single atom, could be drifting through space right now, carrying the mass of an entire mountain, crushed into a point smaller than a grain of sand. You would never see it coming. It would pass through the Earth in less than a second, and you would feel nothing, hear nothing, know nothing, until the planet itself began to change from the inside out. But what's even crazier is that this is the smallest, gentlest entry on this list. Every other black hole gets worse from here. Primordial black holes are theoretical relics from the first fraction of a second after the universe began, formed not from dying stars, but from the raw density of the early cosmos itself. Some may weigh less than a mountain. Others may weigh as much as a planet. If one passed through your body, it would leave a wound narrower than a hair, and you might not even notice until it was already gone. No explosion, no light, no warning. Scientists have searched for their gravitational fingerprints since 1970 and have never confirmed a single one exists. But somewhere out there, one might be older than every star in the sky, a hidden ingredient the equations seem to require in order for reality itself to make sense. And if primordial black holes are this quiet, this invisible, this easy to miss, what happens when a black hole is actually built from something we can see coming? Stellar mass black holes form when a star many times larger than our Sun collapses under its own weight, crushing millions of miles of matter into a point smaller than a city. Cygnus X-1, discovered in 1964, was one of the first ever identified, weighing about 21 times the mass of the Sun. Fall toward one of these, and the difference in gravity between your head and your feet would stretch you into a thread of matter only atoms wide, a process called spaghettification. Your body would not explode. It would simply stop being a body. No bones, no shape, just a stream of particles falling into darkness. And that leaves us with a strange comparison, because as violent as this sounds, stellar black holes are actually some of the smallest true black holes in the universe. Intermediate mass black holes sit in a gap scientists spent decades struggling to confirm even existed, weighing somewhere between 100 and 100,000 times the mass of the Sun. They are too big to form from a single star, and too small to sit at the center of most galaxies. Some may lurk in dense star clusters, feeding slowly on gas and smaller stars for millions of years without announcing themselves. If you've made it this far into the darkest corners of physics, drop a like and subscribe, because the next entry on this list does not just bend space, it starts to make time itself uncertain. Because here is the unsettling part about intermediate black holes. If they are this hard to detect while still being thousands of times heavier than our Sun, what does that say about the black holes we haven't found at all? Rogue black holes are stellar remnants that were violently ejected from their home systems, and now drift silently through the galaxy with no star, no light, no visible companion to give away their position. One candidate discovered through gravitational lensing in 2022 appeared to have no luminous partner at all, detectable only by the way its gravity warped the light of a distant star behind it. If one drifted into our solar system, we might not notice until Earth's orbit began to shift in ways astronomers could not explain. No warning, no signal, just a slow unraveling of the numbers we thought we understood. And this is where things become strange, because the next black hole is not hiding in the dark at all. It is one of the brightest objects in the observable universe. Quasar black holes sit at the center of some of the most energetic objects ever detected, feeding on enormous disks of gas that heat up to millions of degrees and blaze brighter than every star in their galaxy combined. This radiation can be seen across billions of light years, which means when we look at a quasar, we are looking billions of years into the past. But here is the terrifying part. If a black hole this active existed close enough to our galaxy, the radiation alone could strip away a planet's atmosphere long before the black hole itself ever arrived. So what happens when a black hole isn't just a bright light in deep space, but a hidden shape woven directly into the fabric of our own galaxy? Sagittarius A star sits at the center of the Milky Way, weighing about 4 million times the mass of our Sun, and yet from Earth it appears smaller in the sky than a tennis ball would look sitting on the surface of the Moon. It orbits nothing. Everything else orbits it. In 2022, astronomers finally captured a direct image of the glowing ring of matter surrounding its edge, confirming what physics had predicted for decades. It sleeps at the center of our galaxy like a lion at rest, quiet for now, but never harmless. And if our own galactic center is this massive, while still behaving this calmly, the next entry on this list raises an uncomfortable question. What happens when a black hole stops behaving calmly at all? Active galactic nuclei are supermassive black holes caught in the act of violently consuming matter, launching jets of particles at nearly the speed of light out across tens of thousands of light years. These jets can outshine their entire host galaxy and disrupt the formation of new stars for millions of years in every direction they touch. Take a quiet galactic center and feed it a steady stream of gas and stars, and you get an engine capable of reshaping everything around it. The common assumption is that the danger from a black hole comes only from falling in, but active galactic nuclei prove that a black hole can devastate a galaxy from thousands of light years away without anything ever crossing its edge. Binary black holes are pairs locked in orbit around each other, spiraling closer over millions or even billions of years until they finally merge into one. When two of these titans collide, they release a burst of gravitational waves, ripples in space-time itself, first detected directly in 2015. The merger can release more energy in a fraction of a second than every star in the observable universe combined. And right now, somewhere in the dark spaces between galaxies, there could be a pair locked in this slow spiral, counting down toward a collision we will only detect the instant it happens. But nobody knows how many of these pairs exist, and given how faint the signal is until the final moment, nobody ever fully will. TON 618 is a hyperluminous quasar containing a black hole estimated at over 60 billion times the mass of the Sun, so large that its event horizon alone could swallow our entire solar system, engulfing the Sun, Earth, and even Pluto's distant orbit without stretching to its edge. Light from TON 618 has been traveling toward us for over 10 billion years, meaning we are seeing it as it existed when the universe itself was still young. Take a supermassive black hole and multiply it past every reasonable scale, and you get something so large the word massive stops meaning anything useful. But even TON 618 is not the strangest object on this list, because the next entry breaks one of the basic rules black holes are supposed to follow. A naked singularity is a theoretical object where the crushing point at a black hole's center would exist, without an event horizon to hide it, exposing the raw mathematics of infinite density directly to the rest of the universe. Under general relativity, singularities are supposed to always be cloaked, a rule physicists call cosmic censorship. If a naked singularity existed, the equations that describe space and time would stop making reliable predictions. The moment you got close enough to look at it directly, no horizon, no boundary, no safe distance, just the unfiltered center of a black hole staring back. We have never confirmed one exists, and many physicists suspect the universe may forbid it entirely. But its very possibility means our understanding of black holes may still be missing a piece, as fundamental as the ones we've already covered. Across every version on this list, from a black hole smaller than an atom, to one that outweighs 60 billion suns, the pattern never breaks. Gravity does not care about size, distance, or how confident we feel standing on solid ground. It simply waits, patient and silent, the way it has for billions of years, and the way it will for billions more. If you made it through every entry on this ladder into the dark, subscribe before the next one finds you first, and check the playlist below if you are not ready to leave this kind of darkness behind just yet.